The first thing we're going to do is anti-differentiate x plus 7, all divided by x plus 2 times x minus 3. If that bottom line was not factorized, you would need to factorize it. What we can say is x plus 7 over x plus 2 times x minus 3 is equivalent to a on x plus 2 plus b on x minus 3. And what we need to do is find the values of a and b. So what we can say is x plus 7 times x plus 2 times x minus 3 equals, and now we're going to put the right-hand side over the same common denominator. That is x plus 2 times x minus 3. Our top line, though, will become a times x minus 3 plus b times x plus 2. So, looking at that, the bottom lines are the same. If the bottom lines are the same, that means the top lines are the same. So, all I need to worry about is x plus 7 equals a times x minus 3 plus b times x plus 2. Now what I can do with the right-hand side is group our like things together. We have ax plus bx, so a plus b times x. We then have minus 3a and plus 2b. A plus b is the coefficient, the number, in front of our x. The minus 3 plus 2b is our constant at the end. So if we equate coefficients, what we're saying is the number in front of the x on the left-hand side must equal the number in front of the x on the right-hand side. A plus b must equal 1. What we're also saying is the constant on the left-hand side must equal the constant on the right-hand side. So minus 3a plus 2b must equal 7. What we have are two equations, both using a and b. We can solve those using simultaneous equations. When we do so, we get a equals -1 and b is equal to 2. What that tells us is x plus 7 over x plus 2 times x minus 3 equals, we had written a over x plus 2. A is -1, so -1 over x plus 2 plus b over x minus 3. b was 2. 2 over x minus 3. We've now expressed x plus 7 over x plus 2 times x minus 3 as a partial fraction. Now we've been asked to anti-differentiate this partial fraction. We have got the antiderivative of x plus 7 over x plus 2 times x minus 3 dx, we now know is equal to the antiderivative of -1 on x plus 2 plus 2 on x minus 3 dx. Anti-differentiating these two expressions, I get minus log e of the modulus of x plus 2 plus 2 times log e of the modulus of x minus 3 plus c. We can rearrange these using our log laws. Doing so will give us log e of x minus 3 squared over the modulus of x plus 2 plus c. Now, we know there is a restriction on this problem. We know that x cannot equal minus 2. We know that x cannot equal 3. So this solution is true over a domain of real numbers except for minus 2 and 3.